keys.
What do you think the key word in parallelogram is?
Parallel.
Oh yeah.
That's wild.
Parallel. So guess what? A parallelogram is a quadrilateral. What's quadrilateral mean?
4 sides.
4 sides. So we got 4 sides, and both pair of opposite sides are pair of. Wow.
If I could spell, that would be fantastic. I just spelled arrow.
I'm trying to find my tongue.
All right, these next ones you don't have, but we're just gonna go through them together, even though you don't have to write these down. Okay. Properties of parallelograms. I love parallelograms, so they got lots going on. First off, we already said that they're parallel. How do I show that sides are parallel? Like, what do I draw on the figure?
Little arrow.
Arrows.
Yeah, these arrows. So if these have arrows, that means they're parallel. And then you'll see ones that have like 2 arrows. That's because they're parallel to each other, but they're obviously not parallel like this line and that line, obviously. Okay? Other cool fact about parallelograms, your opposite sides are congruent. And what's it mean to be congruent?
Same.
They're the same. So this side and that side are the same. This side and that side are the same. What's the word consecutive mean?
Actually, in order.
Yeah, kind of. Like, you do have it?
Yeah.
Where?
It's in section 3.
Oh no, that's proving that that's different. Kind of like the opposite.
They essentially say
Okay, so consecutive angles mean like this angle and this angle. If I have parallel lines here, these are certain kind of angle relationships called consecutive interior, same side interior. Do you guys remember what's true about those?
they add to an 80.
They add up to 180. Yeah, they're supplementary. So any angles that are next to each other add up to 180. They are supplementary. Okay? Which means if they add up to 180 next to each other, so like these add up to 180 and these add up to 180, okay, these two, that means that the ones that are across from each other are, any guesses? They're equal. Yeah, they're congruent. So far we got opposite sides are congruent, opposite angles are congruent, opposite sides are parallel. Holy cow, I'm sorry. The last thing, diagonals are the things that cross in the middle. Ooh, that was a bad drawing. That's okay. And they bisect each other. What's it mean to bisect? Yeah, cut in half. So like this half is the same as this half is the same as that half. So essentially, in a parallelogram, we just got a bunch of stuff that's the same. The only thing that's not the same are consecutive angles, and those add up to 180. So when in doubt, we're just going to set a bunch of stuff equal. All right, you don't have this one, but you have this one, right?
Yeah.
Okay. All right, so I got a bunch of angles in there. What do I know about angles in a parallelogram? They're supplementary and congruent. Which ones do you want to do? Supplementary or congruent? Congruent, that's probably easiest. Which ones are congruent? The next twos or the opposites? Opposites are the same, so pick one. That's what I was thinking. Yeah. Those two are opposite, and we said the opposite angles are congruent, so we are going to set them equal. I'm going to solve by subtracting x, adding 5, and we get x to be 40. I don't even have to mess with the other angles because I've already solved for x. So that should be a-okay. So we should write that down. Alright. What else we got? This one you guys have, so you don't have this one. But you have this one. What? What'd you say? Why? Because you didn't write it down? Oh, that's too bad. Alright, what do we know? First off, these inside things, are they sides or what do we call them? So elements are inside my parallelogram. Yes, they bisect, but what are they called?
Bisect.
Starts with a D.
Yo.
So diagonals, okay? These are the diagonals. And we said that the diagonals do what?
Bisect.
Bisect. And it means what to bisect? Split it in half. And these halves are equal, okay? So 3y minus 7 has to equal that 2x. And what else has to be true? Yeah, x plus 1 equals y. Both of those equations have both y and x.
Oh,
What?
you plug the x plus 1 into the y.
Yeah. We're going to substitute in this x plus 1 is going in for this y. Okay?
Whoa.
Yeah, whoa.
You can see
What I'm doing over there. Yeah.
board.
So I have 3 times instead of y. I'm going to use that x plus 1
Computer. No.
minus 7 equal to that 2x.
That's not me.
Why?
No, I'm not.
Oh.
Trying to.
Okay, distribute. So I got 3x plus 3 minus 7 equals 2x. Now what? Combine like terms. What can I combine?
3 negative 7.
Yep, so 3x minus 4 equals 2x. Subtract your 2x, add your 4, and you get x equals 4. Guess what else I gotta find?
Why?
Y. What should I do?
Plug it in.
Plug it in right here. Y is how big? 4 plus 1 is 5. Crazy, huh? Crazy. Alright. Let's draw a parallelogram, just because I haven't drawn in a long time. W, X, Y, Z. Says the perimeter is 90. What's perimeter mean?
The outside.
Yeah, the outside, the around part, okay? And it says WX is 5 inches more than 3 times XY. Holy cow. Do I know what XY is? No, so guess what we're going to call it? X. Is that weird to have like XXY? Is that weird? No? Okay. Alright. And then WX is 5 inches more than 3 times that. How do I write that? 3x, then what? Plus 5. How big is WZ? So just how big? Yeah, X. Because our opposites are congruent. And then how big is ZY?
3x plus 5.
Sweet. So we said perimeter is all the way around. So what do I want to do with all those things I just wrote?
Add them all.
Add them all up. Can we do that together? Let's add the x's. 3x plus x plus 3x plus x gives me how much x? 8x plus 10. Yep. Plus 5 and plus 5 give me that plus 10. And we want that to equal 90. Nice. Subtract your 10. 8x equals 80. So x is 10. Does it ask what x is though? No, it says find the sides. So xy and yz are 10. The wx and zy are 35. You think we were done?
You betcha.
Yeah, sure you betcha.
We should not.
Make fun of my accent.
No, just making fun of Norwegians.
Oh.
Offended.
That was not over funny.
Fine.
Alright. I know you're gonna freak because you see proof, but I promise it's not that bad. Turn the page. What's the first thing I write down in my proofs?
I
You're given.
The given, it says I have parallelogram ABCD and parallelogram NMLB. And I know that because they are given. What I'm trying to prove is that this angle M has to be the same as angle D. On quizzes and tests, maybe. Alright, well let's look at our, do you want to look at the big or the small one first?
That stands for
The big.
The big one, okay. I don't think it does though. Oh, the National Major League, maybe? Okay, and the big one, this angle D, what do I know about it? That's a good one. It's congruent to angle B. So I can say that angle D is congruent to angle B because they're what kind of angles?
alternate exteriors. Vertical.
I appreciate it. They're just opposite in our parallelogram.
Opposites.
Okay? And we know that, because I told you in that whole little spiel, that opposite angles are congruent.
What's a spiel?
A spiel is just like a long, it's like shorter than a lecture.
Hold on, wait, you know my English.
Because in a parallelogram, we know that opposite angles are congruent. That's just like a property of parallelograms. Yeah. If you look at your small one, I know that B and M have to be equal too. So angle B has to be congruent to angle M for literally the exact same reason. Opposite angles are congruent. Okay, here's where we're testing you. There's a one-word reason as to why we can do this. Why can I say what I want to say, that M is congruent to D? Using these two things, what do they both share?
Angle B.
They're
Angle
both
B.
angles.
Do you remember what we talked about, that property when I take out the middleman? And just the outsides? Starts with a T. Yeah, the transitive property. If they're both congruent to the same thing, then they have to be congruent to themselves. That wasn't like horrible. Just that last step was bad. Alright. No more proofs today. Last thing that we are going to talk about is our parallel lines. Kind of like what we did with proportions, except for this is even easier. We don't even have fractions going on. All it says in that little theorem 6-7 is that if you have one side where it's all congruent, your other side has to be all congruent. Okay? So in that first example you have, that's this one, right? Yeah. It says that EF, FG, and GH, so all of these are 6. So would you say that these are all congruent? Okay, so that means that on your other side, this side right here, all of these have to be congruent. Okay, and then we're given that AD is 15, so from here to here is 15. What should each of these be? 5. Oh man. So then from C to D, that's how big? 5. So you don't even have to set up fractions or anything like that. Alright, I think you have this one, yep. Okay, do I have one side that's all congruent? Yeah, so I know that this side has to all be congruent. A to E is 100. And how many different sections do I have? 4. So what's each section? 25. So this is 25. This 25. If I want to know what it is from B all the way to D, how much is it? And then that last one you have in your notes.
The lines are parallel.
Woo! I was just gonna read it. Yeah. It wants to know why they're not correct. Your lines aren't marked with arrows, so you don't even know that they're parallel, so you can't do this. In order to do this, you have to have parallel lines, and in that bottom one, they don't show the parallel. So if you just want to write not parallel, that takes care of that. Alright, questions?